Hello, I'm Joseph. I wanted to talk about using Zig to make a library that's available to C. So it's not the reverse story, it's just to make Zig so that you can later use it into C code. And there's a lot of benefits to that. You have access to allocators, to hash maps and array lists, a bunch of like, nice to haves that are kind of a pain in C to deal with, either via the macro system or these kind of like overly bloated things, libraries out there. So as I say that, though, it's going to come back to hit you on how much code is actually generated. Okay, Zig already talks about this exporting a C library. There's not really much to say about this. There's not much documentation on this at all. And the big thing I will point out here is this does not seem to be true. You can only export functions at this time. I've tried variables, I've tried types. They do not export out correctly unless struct and union and enum are not types, which I think they are. You can't export them. So you're just limited to functions unless you export as a C file rather than a header. And I'm going to talk about that a little bit. The other thing is that there are currently bugs on the generation of the header itself. If you can generate the header, it's missing this Zig target alignment thing, which you can pull from the C version. I'll show that. But if most often than not, you'll get an assertion, failure, blah, blah, blah. I already get this myself. So if I go ahead and try to emit out a header file, I just get this here. I get some memory allocation, blah, blah, blah crap. I can't generate a header file. If I make it simpler, I do not use an allocator, it seems to be fine. But then I still need to generate the C file in order to get the subsequent max Zig alignment, which is in the C files themselves at the very top here. This is per platform, per architecture. So you don't want to copy this verbatim for like everything because the max int alignment might be different than it is, on an ARM system versus an x86 64 system. Who knows? It's whatever Zig's defining there. Okay, so there's that. The other part I have to mention is that if you're going to be using allocators and comp time, things are very special to Zig. You can't use them as parameters to be exported out in a function. To kind of drive this home real quick, if you go and I was trying to allow the use of GPA or general purpose allocator as well as arena, and when I tried to do that, I was passing it in as a parameter to other functions, and I tried to export the function for C interop, and it just wouldn't let me. And then the same thing with comp time. If you do use comp time for anything, you can't export any of the comp time functions, which is obviously, like a no-brainer because what are you supposed to do with this in C? Nothing. Okay, so there's that bit. Now, in terms of compilation, I'm going to go back to my build.sh. We have the basic bit here, which is to export out a header file. This will most likely fail, but it will at least generate the dylib.dll.so. If not, then you could fall back to generating a C file, which then you don't need the dylib or dll.so because it's all embedded into a single C file. That's what I showed here, but this is 100,000 plus lines of code, plus an additional 30,000 lines of code in the zig.h, which if you don't know where to get that from, that is in the distribution that you have with Zig. So if I type in, at least on macOS, where is Zig, and then I do in lsla on this here, you'll see that there is the directory itself, there is a lib folder, and inside that lib folder, there is zig.h. So that's where you would pull it from. And in fact, when I do my build command, I specify that for the compilation of my C version as the include path for zig.h. So pretty simple. Not much else to that. I think these commands are pretty easy to follow, and you can output as LOVM, WASM, a bunch of other stuff on there. If you do zig build lib dash help, it'll give you all the commands here that you can run along with it, as well as the export options for the specific output types for the formatter here, wherever that's at. So it's anywhere there. The other little gotcha I will mention is that if you're building for Windows and you're not using GCC, but you're targeting MSVC, as is the CABI, and you're trying to cross compile, you're going to need the libs anyways. I already made a video talking about that anyways. But the crux of this is If I type in MSVC, this is my MSVC command to compile my dylib or DLL or whatever else. But on Windows it'll be a DLL, and I need to specify the C++ compiler libs, the Windows SDK 10 libs as well for both UCRT and pretty basic, but I had to go pull these from my Windows system. I had to download Visual Studio 2022 and grab these libs, because if not, it will complain about these libs missing up down here somewhere, and then you need to go find them. And there are debug versions and non-debug versions. The D suffix is why that is a debug there. So pretty straightforward. Now, in my use case, the only really big thing I'm kind of stuck at right now is comp time. I am using comp time and exporting it out just fine. It's just the resulting headers and everything else, even without comp time, by the way, they're not consistent. Meaning that when I go to my main.c, this is the comp time structure that is generated. This changes every time I do a new build, or I change my information in my build about that. And the only way I even know how to find that is if I go into the generated C file itself, look for that function, and then see the representative struct here. And even when you generate the header file, the structs are missing, and they also follow the same issue. So if I go to main.c, which was the non-comp time version, it's a little bit more manageable. There's like a little bit of a suffix of a number, but in general, you don't have this available to you. You need to rewrite this by hand in your C code, because it's not exported out. Like I said, export on the structs and enums and unions do not work currently that I'm aware of. It'll error out as a type. So yeah, that's the only little gotcha there. And so what I do right now is I just do a type def to rename it. So at least it's in one spot, but I would have to just find some way to automate this. And then the last bit here is in my comp time as well. A way I would want a way to automate these functions, so I don't have to like hand roll it out every single time for every different type. It's not much now. It's like 30 lines of code at most per type, and there's like 30 different types in Zig that Raylib that I would want to expose. But in general, it's cool. It's cool to have access to allocators. It's cool to have access to the hash map here. If I can actually find it, hash map, array list. I have all this luxury now inside of Zig that's available to me now in C that I can go and use with Raylib itself. So if I need to do some tracking of resources, I can use Zig to do that, and then C to just do the rest of the lifting parts if I need it to, which I don't really want to do. My point is to use Zig for a full rewrite of my library here. And this is what I'm doing currently in C for everything that I just showed you in Zig. So I already made this part, kind of done, but I need to do the whole circle of life thing here, where I'm doing the reverse of getting all of C stuff into Zig itself. That will be a separate video that I will talk about, because there is a lot more wrong with that side of stuff than it is getting Zig into C itself.